Okay, today we are looking into the combination. We learn about the discrete random variables, but what if we have combination of the few discrete random variables? For example, if we have random variables x1, x2, and x3. And for example, we can consider random variable as x1 plus x2 plus x3. And each of them have its own expected value. And own variance of x1, variance of x2, variance of x3. Let's see how we can find the expected value and variance of the combination of those random variables. Let's, for example, consider that we have three identical distributions. For example, let's say we have some random variable. So we have x1, x2, and x3, all are the same. So effectively we're looking for sum of three identical random variables. Let's consider the next distribution. X can take values 0, 1, 2. Probabilities x equals x will be 1/3, 1/3, 1/3. So, and we need to find probability first, let's find probability distribution of x1 plus x2 plus x3. What will be, now we have x equals x1 plus x2 plus x3. So what will be the possible values of new random variable? When we add all three identical, what will be the possible values of x? We can have at 0 plus 0, 0 plus 1, 0 plus 2,
0,
1 plus
2.
So there will be 0. We can have 1. We can have 2, 3, 4, 5, and 6. So that now new variable can take all those values. Now let's find what will be probability x equals x. And how we will find each probability using multiplication law. So probability of 0, we have each of them has to be equal 0. So what will be the total probability of all three equal 0? We need multiply probability of each 0, so we'll get 1 on 27. Now, to get 1, how we can get 1? We can get 1, 0, 0, 0, 1, 0, 0, 0, 1. So there are three possible. For each of them, what will be the probability of each of these combinations? 1 on 27, but we have three of them.
9.
So it will be 1, 9. With 2, if we will list with 2 that we will have, it can be done in more ways, because we can have 1, 1, 0, 1, 0, 1, and we can have 2, 0, 0, 0, 0, 2. So that will be 2 over 9. And then will be 3 will be 7 on 27. 4 again 2, 9, 1, 9, and 1 on 27.
Will it always be like that? Or like symmetrical?
Symmetrical. If for such distribution it will be symmetrical, but if they will be like not all the same, because it's not necessary that all random variables are the same.
Yeah.
So it's not necessary will be symmetrical.
That's fair.
Now, what will be, let's find the expected value. Finding it in the exactly same way as we usually do, multiply x by probability of x and add all them up. If we do that, we will get 3. Now, what is expected value, by the way, we have not calculated here, what is expected value of this?
1.
Will be 1/3 plus 2/3 will be equal 1. What will be variance? For this one.
5 on 3 minus 1, which is just 2.
So we will have, we need to square those. 0, 1, 4.
Yeah, it will be 2 and 3.
Will be 1/3 plus 4/3, we get 5/3.
Minus 1.
Minus 1 will be 2/3.
So,
If we calculate variables, variance of this x, square each of them and add, we will get, it will be equal to. So standard deviation here will be the square root of 2/3, and standard deviation here will be equal.
what do you do with standard deviation? 2 times by what? 3?
Standard deviation is the square root of variance.
No, of course, but to get it to this, to the other side.
How I got 2? How I get 2? Square this. 1, 4,
you said
9,
2, because the way.
16, 25, 36 times and added them. I just have it's already calculated, so
I
we
thought
don't. We
you had a
don't.
way of translating it.
No. We're just doing it separately.
Okay.
And then we will see what the relationship will be between those values and those values.
Can I guess what the standard deviation is?
For here, if we calculate variance, it will be big guess.
Oh,
Okay, guess it.
I
What
just
will be?
realized you have the variance of the thing here. Never mind.
It will be square root of 2. Now let's compare what we've got. So as you can see, we have expected value of x1, we have expected value here 3.
The times here by the reciprocal.
So we add them. We will have that expected value x1 plus x2 plus x3 will be equal expected value of x1 plus expected value of x2 plus expected value of x3. If they all the same, that will be equal just 3 times e of x. If you have n same variables added, if you will have n same random variables added, what will be the expected value of this x plus x plus x plus x n time? What will be the expected value? Can you see the pattern? N times e of x will be equal n times e of x. So when we have expected value, we add n same variables. If they're not the same, we add expected values, but as they all the same, we just multiply by n. Now, what we can see if you look on the variance.
The variance is also times by n.
So we will have variance x will be equal, in this case, 3 times x plus x plus x will be equal 3 variance x.
Oh, and here. I can see that.
So we have, when we have variance of x1 plus x plus x plus x n times, that will be equal n times variance x.
And then,
So we multiply, if we have n variables, we multiply expected value of the sum by how many of them, expected value, same thing, yes.
and standard deviation is times root n. Like root n times.
And standard deviation times by
root n. Yeah.
root n.
So that.
Not by n, but by root n, because obviously standard deviation is the square root of the variance.
Amazing.
This is a sum. What if we have
Product.
the product of the random variables? And we'll consider again on the example first before getting to the So let's consider the next example. If we have, again, we have random variables let's say we roll normal die. We roll normal six-sided die.
Yeah.
And we roll it twice, and we multiply let x represent the number observed when a fair die is rolled. What we can get? When we roll once, we can have 1, 2, 3, 4, 5, 6, and probabilities obviously will be all 1/6. If it's a fair die. But what will be if we will consider we double the result? We roll a die and we double it. So what x can be? Now, we have 1 times 2 is 2. We'll have 2, 4, 6, 8, 10, 12. But the probabilities will remain the same. It will be the same probabilities. Probability x equals x. We have 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. So let's find, this is 2x, pretty much probability 2x. So what will be expected value of 2x? We multiply, as usual way, 2 times 1, 6,
1
times
plus
6,
1
and
plus 3 on 2.
so we will get expected, by the way, what will be expected value here? What will be
Six
expected
plus
value
a third.
here?
Plus
If we
a half.
calculate,
Plus 2/3.
11 on 6. Sorry, 21 on 6. No.
No,
will be
11,
21 on
15,
6.
18, yes.
will be
21
21
on
on
6.
6, which
21.
is 3.5.
Dang.
Let's calculate expected value here.
I'll just, oh, can I just tell me by
It will be
square?
7.
Yeah, 40.
It will be 40. It will be 42 over 6. It will be 7. So what we can see when we have expected value of nx equal n times expected value of x. But what will be the variance? If we calculate variance, what the variance here? What variance we will get here if we square those numbers 1, 4, 9, 16, 25, 36, and we calculate it, we will get that variance x will be 35 on 12.
So that'll be 35 on 6.
Now, this one,
No.
no,
Oh.
no.
2, 3, 2, 3.
If we
What is
calculate,
square?
we will get the variance
35 squared 144.
of 2x
Ah,
will be equal, if you do the fractions, we will get 35 on 3. Because
Why
we will
three?
get,
times 4 is 2. It's squared. Chill.
So we have now the variance of nx equals n squared.
We learned this in methods.
Variance x, huh?
We learned this in methods.
Yeah, I know.
Yeah.
So for you, it's another revision before your exam. So when we have product, when we have sum, we add them. But when we have product of random variable, we have n squared times variance x, and standard deviation of nx will be equal n times standard deviation of x. Before, when we have sum, we multiply by root n. When we have product, we multiply it by n. So it's not the same thing, the sum of random variables or product of random variables. We get different results. Make sense? And let's do one example. Let's do one example, and then you can do practice. The example that I wanted.
Do you act like a big example?
Yeah.
Just pull out a, pull out a,
All my definitions.
like a thing.
Right, 1 second.
Insane.
What folders?
Insane. Get Mr. Victor anybody.
He gave us examples.
You take your seats. Take your seats.
I don't want Jesse's.
Why?
My definitions on
Okay, for my example that I wanted to do with you.
Oh yeah. Go show man.
So let's consider the next example. We have discrete
I'm so far from it.
so we have some random variable q, and we don't know its mean, and we don't know its variance and standard deviation. But we know that expected value of 5q equal 2100, and we know that variance of 5q equal 275. Question is, what are the expected value and variance of the q? We know that expected value of 5q
Just divide by 5.
of 5q equal 5 times expected value of q. So then we have expected value of q, we just divide by 5, 2100 divide by 5 equal 402. Make sense? Now variance, we have that variance of,
Is it like a fifth root of that?
no, variance of 5q equal 25, 5 squared
Yeah,
times
yeah.
variance q.
11.
So we will have that variance q will be equal
11.
275 divided by 25. Yes, you're right. It will be equal 11.
Perfect.
That's all for today. Like, subscribe, and donate to help fight terrorist countries and organizations, Russia, Iran, Hezbollah, Hamas, etc. support Ukraine and Israel.
Yes.